Have you ever wondered where the universe came from? It's a question that has puzzled humanity for centuries, sparking countless theories and debates. How did all this, stars, galaxies, even us, come to be? What is the origin of everything we see around us? The answer, most physicists believe, lies in an event called the Big Bang. This monumental event marks the beginning of the universe as we know it. This theory, supported by a lot of evidence, describes the universe's incredible journey from a tiny point to the vast expanse we see today. It's a story of transformation and evolution on a cosmic scale. The Big Bang theory isn't about an explosion in space. It's a common misconception. Instead, it describes the expansion of space itself, a continuous process that has been happening for billions of years. Imagine the universe like a balloon being inflated. As it grows, everything on its surface moves farther apart. As the balloon expands, points on its surface move farther apart. This is a simple way to visualize the complex nature of our universe's expansion. Similarly, galaxies are moving away from each other as the universe expands. This ongoing expansion is a fundamental aspect of our universe's nature. About 13.8 billion years ago, the universe was incredibly small, hot, and dense. It was a singularity, a point where all the mass and energy of the universe were concentrated. We're talking smaller than an atom. Imagine all the galaxies, stars, and planets compressed into a space tinier than a single particle. This state is almost unimaginable. It's hard to fathom such immense energy and matter packed into an infinitesimally small point. Then, bang! The universe rapidly expanded and cooled. This event, known as the Big Bang, set everything into motion. This wasn't like an explosion in space, but rather the expansion of space itself. Space stretched, carrying galaxies with it. In the first fraction of a second, the universe was a chaotic soup of energy. Temperatures were unimaginably high, and particles were in a state of constant flux. As it cooled, this energy began to condense into fundamental particles. Quarks combined to form protons and neutrons. Think of it like steam cooling to form water droplets, but on a cosmic scale. This process was the beginning of matter as we know it. These particles would eventually become the building blocks of everything we see around us. From the smallest atom to the largest galaxy, it all started here. As the universe continued to cool, these fundamental particles combined to form protons and neutrons. These protons and neutrons then came together to form the first atoms, mostly hydrogen and helium, the simplest elements in the universe. This early universe was still extremely hot and dense. Imagine a fog so thick you can't see your hand in front of your face. But within this cosmic fog, the seeds of future structures were being sown. Tiny variations in density would later act like gravity wells, pulling in matter and eventually leading to the formation of stars and galaxies. Section 4. Gravity's role, shaping the cosmos. Gravity is the architect of the universe. In the young universe, gravity caused those denser regions of hydrogen and helium to clump together. These clumps grew larger and denser, pulling in more and more gas. As these gas clouds collapsed under their own gravity, they heated up immensely. Eventually, the temperature and pressure at the centers of these collapsing clouds became so great that nuclear fusion began. Hydrogen atoms fused to form helium, releasing tremendous amounts of energy. This is how the first stars were born, lighting up the early universe. Section 5. Birth of stars, galaxies and planets. Stars didn't form in isolation. They emerged from vast clouds of gas and dust, known as nebulae, where gravity played a crucial role in pulling these particles together. Gravity pulled them together into vast collections called galaxies. These galaxies are not static, they interact, collide, and merge, creating even larger structures. Our own Milky Way galaxy is just one of billions of galaxies in the observable universe. Each galaxy is a unique and dynamic system, constantly evolving over billions of years. Each galaxy is a swirling city of stars, gas, dust, and planets. These components interact in complex ways, leading to the formation of new stars and planetary systems. Within these galaxies, new stars continue to form. The process of star formation is ongoing, with new stars being born from the remnants of older ones. As stars age and die, they release heavier elements into space. These elements are crucial for the formation of planets and life as we know it. These elements, forged in the hearts of stars, are the building blocks of planets like Earth. Over time, these elements coalesce to form new planetary systems. Our planet and everything on it, including us, is made from stardust. This connection to the cosmos is a reminder of our place in the universe. The Big Bang Theory paints a picture of a universe that is constantly evolving. From the initial explosion to the present day, the universe has undergone tremendous changes. From a tiny point to a vast cosmos teeming with stars, galaxies, and planets, the story of the universe is one of incredible change and complexity. Each stage of cosmic evolution has contributed to the universe we see today. Understanding the Big Bang allows us to trace our cosmic origins back to the very beginning, connecting us to the universe in a profound way. This knowledge not only satisfies our curiosity but also deepens our appreciation for the cosmos.